Welcome to Omni Eyes. Today, we explore the secret world of the pangolin, uncovering the incredible mysteries of its biological armor. Hidden deep within dense tropical forests, this elusive creature navigates the dark undergrowth, using senses far beyond our human comprehension daily. Unlike many other mammals, the pangolin does not rely primarily on its eyesight to survive in these harsh and unforgiving environments. Instead, it depends heavily on its extraordinary sense of smell and incredibly acute hearing to locate its tiny, hidden insect prey. As a nocturnal hunter, the pangolin spends most of its life either buried underground or foraging quietly under the moonlit sky. Vision takes a back seat, but the biological mechanics of its eyes still reveal fascinating evolutionary adaptations designed for ultimate survival. To understand this unique creature, we must look closely at how its eyes have adapted to a life of constant digging. The primary diet of this armored mammal consists entirely of ants and termites, found deep within tough mounds and subterranean tunnels. When attacking a termite mound, the pangolin faces a massive swarm of angry, biting insects, defending their home with absolute ferocity. In such extreme conditions, delicate organs like the eyes need specialized protection mechanisms to prevent severe damage from dirt and bites. Nature has equipped the pangolin with a remarkable biological shield, known scientifically as the nictitating membrane, or the unique third eyelid. This semi-transparent layer sweeps across the cornea, acting like a built-in pair of safety goggles against flying debris and angry insects. When the pangolin aggressively digs into the earth, this membrane automatically deploys, sealing the sensitive eye from sharp soil and dust. Because the membrane is partially clear, the creature does not lose its vision completely when its eyes are fully covered up. It can still detect basic movements and shifting light patterns, allowing it to remain aware of potential predators lurking nearby constantly. Imagine wearing heavily tinted glasses during a sandstorm. You remain protected while still maintaining a crucial awareness of your immediate surroundings. This incredible adaptation ensures that the pangolin can feed efficiently without risking permanent blindness from the defensive bites of angry termites. As the sharp claws tear through the hard soil, a massive cloud of dust completely engulfs the animal's face and eyes. Yet, beneath the protective shield of the nictitating membrane, the delicate cornea remains entirely untouched, perfectly preserved from the abrasive dirt. Even when the pangolin curls into its famous defensive ball, this inner eyelid remains active, guarding against any unexpected environmental hazards. The muscular control of this third eyelid is entirely involuntary, responding instantly to the slightest touch or sudden change in pressure. Researchers marvel at the sheer efficiency of this biological mechanism, a perfect example of evolution solving a highly specific environmental problem. Without this translucent barrier, a single ant bite to the eye could easily lead to severe infection and ultimately cause starvation. The continuous sweeping motion of the membrane also helps to distribute essential moisture, keeping the eye perfectly lubricated during long hunts. It acts as a biological windshield wiper, clearing away microscopic particles that manage to bypass the creature's thick, armored facial scales. Every time the pangolin blinks, it reinforces a vital line of defense, ensuring its limited vision remains as clear as possible. This elegant solution highlights the incredible resilience of nocturnal burrowers, adapting to habitats that would quickly destroy more sensitive visual organs. Observing this membrane in action requires high-speed macro photography, revealing a lightning-fast reflex that operates entirely beneath our normal human perception. The sheer speed of the membrane closure is a testament to millions of years of relentless evolutionary pressure and survival instinct. It is a microscopic marvel of biomechanics, demonstrating how life constantly innovates to protect its most vulnerable and essential sensory systems. Beyond the protective outer layer, the internal structure of the pangolin's eye reveals even more fascinating secrets about its nocturnal lifestyle. The retina is almost entirely composed of rod cells, specialized light receptors designed exclusively for maximizing vision in extremely dark environments. Because rod cells are highly sensitive to low light, the pangolin can easily navigate through dense forests under a moonless sky. However, this incredible night vision comes at a significant cost. The creature possesses almost no cone cells for detecting vibrant colors. To a pangolin, the vibrant tropical jungle appears as a muted landscape, composed entirely of contrasting shades of gray and black. It cannot appreciate the brilliant green of the leaves or the bright warning colors of dangerous predators hiding in the brush. But in the pitch-black darkness of an underground burrow, color vision is completely useless, making this evolutionary trade-off incredibly highly efficient. The dense concentration of rod cells acts like a natural night vision camera, amplifying the faintest glimmers of ambient starlight and moonlight. Fine visual details are also sacrificed. The pangolin sees the world in relatively low resolution compared to eagles or hunting felines. It does not need to spot a tiny insect from afar. It only needs to avoid large obstacles and approaching predators. Once an obstacle is detected visually, the animal's superior sense of smell immediately takes over to analyze the object in detail. This combination of low-resolution night vision and high-definition olfaction creates a perfectly balanced sensory system for a dedicated nocturnal foraging lifestyle. The visual world of this armored creature is a realm of shadows and silhouettes, perfectly suited for a life spent hiding. Evolutionary biology shows us that nature never wastes precious energy on developing complex sensory systems that an animal simply does not need. Maintaining high-resolution color vision requires massive amounts of metabolic energy, which the pangolin wisely conserves for digging and digesting tough insects. Every calorie saved from visual processing is redirected towards powering its incredibly strong claws and maintaining its heavy, impenetrable, scaly armor. The optic lens itself is relatively large, designed to gather as much ambient light as possible before focusing it onto rods. When a sudden flash of bright light hits the eye, the hypersensitive rod cells can become easily overwhelmed and temporarily blinded. This is why pangolins are highly vulnerable to poachers using artificial spotlights, a tragic consequence of their specialized nocturnal biological design. Understanding the limitations of their vision helps conservationists develop better strategies to protect these critically endangered animals from human-caused environmental threats. Moving outward from the retina, we discover another critical defensive feature: the physical placement of the eyes within the animal's skull. The eyes are set incredibly deep inside thick, reinforced bone sockets, surrounded by a tough layer of specialized protective muscle tissue. This recessed positioning creates a natural physical barrier, shielding the delicate eyeball from direct impacts while moving through dense, thorny underbrush. When the pangolin thrusts its head into a narrow termite tunnel, the protruding skull bones take the brunt of the friction. The deep sockets also protect the eyes from the desperate, swarming attacks of soldier ants trying to defend their queen's chamber. If a predator attempts to strike the animal's face, the deeply sunken eyes are far less likely to suffer catastrophic damage. It is a structural defense mechanism, complementing the dynamic defense of the nictitating membrane and the heavy armor of the scales. Looking closely at the skull architecture, one can truly appreciate the rugged, fortress-like design that evolution has carefully sculpted over millennia. The surrounding skin is thick and leathery, providing an additional cushion against the sharp rocks and roots encountered during frantic digging. Even the eyelashes are modified, acting as stiff sensory bristles that trigger the blink reflex long before an object makes contact. This multi-layered defense system ensures that the pangolin's vision, though limited, remains functional throughout its long and incredibly physically demanding lifespan. Biologists studying pangolin anatomy often note how every single physical trait is optimized for surviving in a hostile, subterranean, insect-filled environment. The deep-set eyes give the creature a distinctively cautious and gentle appearance, masking the incredible strength hidden within its muscular frame. As it navigates the dark forest floor, the recessed eyes remain safely tucked away, scanning the shadows for any sudden movement. The skull's geometry perfectly balances the need for sensory input with the absolute necessity of physical protection against constant environmental abrasion. Nature has effectively built a biological helmet around the pangolin's visual organs, a masterpiece of natural engineering and evolutionary problem solving. Every time it rams its head into a dirt mound, this helmet absorbs the shock, keeping the fragile optic tissues intact. This structural resilience is a key reason why pangolins have survived virtually unchanged for millions of years in challenging tropical habitats. They are living relics of an ancient world, perfectly adapted machines designed to consume insects and withstand immense physical punishment daily. The deep eye sockets are just one small piece of a much larger, incredibly complex puzzle of biological survival and adaptation. Perhaps the most fascinating aspect of pangolin vision lies not in the eye itself, but deep within the complex mammalian brain. The optic nerve, which transmits visual data from the eye to the brain, is surprisingly thin and structurally simplified in pangolins. This reduction in the visual pathway represents a profound evolutionary concept, known among scientists as strict neurological resource reallocation and adaptation. Brain tissue requires massive amounts of energy to maintain, so the pangolin has drastically reduced the size of its visual cortex. The neural real estate once dedicated to processing complex visual imagery has been entirely reassigned to other, far more crucial senses. The olfactory bulb, responsible for processing smells, is massively enlarged, dominating a significant portion of the creature's specialized anterior brain structure. This allows the pangolin to detect the faint chemical trails of termites buried several feet beneath the solid, hard earth surface. Similarly, the brain regions dedicated to processing tactile information from the snout and claws are highly developed and incredibly densely wired. When a pangolin touches the soil, its brain receives a flood of high-definition sensory data, mapping the underground world through vibration. It literally feels and smells its way through the darkness, constructing a mental map far richer than anything its eyes provide. This neurological trade-off is a hallmark of burrowing animals, perfectly illustrating how evolution shapes the brain to match the ecological niche. By sacrificing visual processing power, the pangolin has achieved absolute mastery over the chemical and tactile realms of its dark environment. It is a beautiful example of biological efficiency, where nothing is wasted and every neural connection serves a highly specific purpose. The simplified optic system still processes enough information to govern circadian rhythms and detect the looming shadows of dangerous approaching predators. But the true intelligence of the pangolin lies in its nose and its claws, guided by a uniquely specialized brain architecture. Studying this neurological reallocation provides scientists with valuable insights into how mammalian brains adapt to extreme environmental pressures over evolutionary time. It challenges our human-centric view of the world, reminding us that vision is just one of many ways to experience reality. For the pangolin, reality is a rich tapestry of sense, vibrations, and textures, a hidden world completely invisible to human eyes. Their unique sensory perception allows them to thrive in environments where visually dependent predators would quickly become disoriented and eventually starve. The brain of the pangolin is a masterclass in evolutionary optimization, perfectly tuned to the specific demands of its unique lifestyle. From the protective sweep of the nictitating membrane to the deep-set sockets and specialized retina, the pangolin's eye is truly remarkable. It is a sensory organ completely redefined by the harsh realities of a subterranean, insect-hunting existence in the dense tropical forests. While it may not see the world in vibrant colors or sharp details, its vision perfectly complements its other extraordinary senses. The neurological reallocation of its brain ensures that it remains the undisputed master of its dark, hidden, and incredibly complex domain. Understanding these biological marvels is crucial for appreciating the incredible diversity of life on Earth and the urgent need for conservation. We must protect these gentle, armored creatures, ensuring that their ancient evolutionary secrets are not lost forever to human greed and ignorance. Thank you for joining us on this incredible journey today. Subscribe to Omni for more fascinating explorations of the natural world.